my name is Megan. Today, in Autodesk Civil 3D, I will demonstrate how to use existing data to create CSV files that contain decimal degree latitude and longitudinal points. These can then be used to render your data as a 3D model in the ProVision AR app. We will begin this process by opening the existing drawings with the utility data. And then you're going to open up a new drawing, and in the tool space under settings, right click on drawing, edit drawing settings, and we're going to assign it a coordinate system. I am in the US, Minnesota, and I'm looking for St. Louis County, South US feet. Make sure you use the right coordinate system and the right units for your project, and then you can save the drawing. Step is to turn on Ariel Imagery and find the project location. So after defining the coordinate system for the drawing, this geolocation tab will pop up. Click on it. The map will be off right now. You can choose Map Ariel or Map Hybrid. And then zoom out until you see the map. There it is. And zoom into your project location. Now that you've zoomed into your project location, find that reference point to copy and paste the data from. So here you can see I've got this sanitary manhole and this water valve. On the imagery, if I zoom in, I've got that water valve and that sanitary manhole. So I'm going to use the sanitary manhole. Before I get too far, I need to remove some of this data. There's too much, more than I need. All right, now that I've narrowed it down, I am going to just select everything here. If you missed a piece, just zoom in and select it. And then right click, clipboard, and copy with a Basepoint. That Basepoint is going to be that sanitary manhole. Come back over here to our new drawing, right click, clipboard, paste. And then select the spot. And at this point, you can turn off your imagery if it's hard to see your lines. And there you have it. All right, so I added in the rest of the data from this other drawing here, just connecting it to the sanitary lateral. And now we have to create points at the end of all of our vertices. You can see there's already some points here and up here, but we're going to create new ones so that we know they all have it. And I kind of do each utility through all of these steps, and then I come back to this step. You'll see what I mean as I move forward, but type in point, enter, put it right at the end, going to each vertice, continuously hitting enter. And it's important you follow a line continuously through instead of jumping around from this line to that line, or even just mixing up the vertices going from start to end and then mixing them in the middle. And I will explain why later. Our next step is to create COGO points. So just under the Home tab, go to Points, Convert to AutoCAD points, and select all of those points we just created. You can zoom in more if you need to make sure you're selecting the right point. And then once you have them selected, hit enter, and we're just going to give them a name. So I know this is storm drain. So I'm just going to do STRM, and you have to type it for each one. And then when you've typed it and named them all, just hit enter again, and you'll see that there's a red X over those points. Our next step is to create a point group. So under the Prospector tab here, you can click on points. You can see the 6 points that we created to create this line. And under point groups, you can right click, new. Come up with a unique naming convention, because you're going to want each of these to be different. So I'm going to do Storm 1, include selection set in drawing, zoom in and just select those 6 COGO points that we just created, and then hit enter. You can see the point numbers are there. Here you can also change the style, the point style, and the point labels if you'd like. This is just the default labeling, so you can see that they've been added to this point group. Now, when you're creating point groups, be careful to only have continuous lines. So I'm going to have this one, these 6 be their own point, these laterals will be their own, this lateral will be its own, and then you kind of have bends in it. So this lateral with this entire storm line will be one, but this storm lateral is going to have to be its own point group. This next step is a little tedious, but it is very important to the process. Come to the Output tab up here, and then we're going to hit Export Points. And our format is what we're going to be changing. They've got a lot of different formats here. We're going to create our own. So just click on the button to the right, New. We want a user point file. And then name it whatever you would like. I am going to do lat long. Default extension, we want it to be CSV delimited by a comma. Then come down here to these columns, and it says unused. Just click it once, then a new pop-up comes up. Change the column name to the DEC DEG latitude. If you'd like to add a null indicator, you can, and I like to increase my precision. And there you can see we've got the decimal degree latitude. Now we need to do decimal degree longitude. And increase our precision. And if you have elevation associated with any of your points, you can add in point elevation. Otherwise, I want the default to be 1 for the depth column, which I'll explain in a little bit. And when you've got that all squared away, just hit OK. And you can see it's created our new one. Hit close. And that's how you create a new point format. So I still have up my export points box here, but again, it was just output, export points. Here we are. I input our custom format, and we want to limit this to a point group so we don't get all the points. Storm 1, and then specify which file you would like it. And I name it the same thing, Storm 1, open, and OK. And that exported it to a CSV. Open up File Explorer and open up that newly created CSV. It'll open in Excel. You can see our 3 columns here. We've got the latitude, the longitude, and the elevation, which we refer to as depth. Right click on that first row, insert. We need to give them headers. So just type in latitude in column A, longitude in column B, and depth in column C. Now it is really important that the depth column has values or it won't load properly in our app. So I give it a depth of 1, which is like below ground. The positive values go down and the negative values would go up above ground, ground being 0. So I just give it 1 for 1 meter below ground. It will be symbolized in more of a translucent color when you add it to a project. And it's really important here that our points are in order from beginning to second all the way to the end. We don't want the points to be jumping around because otherwise our line will not render properly. This is the process that has to happen for each continuous utility line segment. This was an example of just one segment. Once I finish this project, I will have about 28 different segments and CSV files associated with them. After all of the CSV files are created, check out Craig's video on how to upload them to a project on the Virtual GIS website using your account. The links are below. Thanks for watching.